Welcome back to Daniel Maths Academy. This is Monday JAMB Maths for Maths series with Daniel. Right, so before we dive in, we want to appreciate our community, people that have been following us from our daily posts. We say thank you for what you've been doing and taking on with us. Now, one of the ways that we can make this video to go around is by subscribing to this channel, hit the notification button so that new content will be sent to you directly. Don't forget to comment and send your comment, and also remember to like and share this video to people that really need this. With that out of our way, let's dive into today's question. So look at question one. Question one here says find the derivative of y equals to x to the power 7 minus x to the power 5 divided by x raised to the power of 4. So let's write this question out. So this is giving us x raised to the power y equals to x raised to the power 7 minus x raised to the power 5, all divided by x raised to the power 4. X raised to the power 4. So let's solve this quickly. Now what we need to do is to simplify this further. Now to simplify this, what we need to have, we have that y is equals to, so we're going to use x raised to the power 4 to divide x raised to the power 7 minus this. So this can be written as x to the power 7 divided by x to the power 4 minus x to the power 5 divided by x to the power 4. So if we go further from there, we'll have that y is equal to, so here we can apply indices. All right, this is going to give us x to the power 3 because 7 minus, so this is indices. Now same base, different powers, so you just take one of the base and subtract the powers. Division is subtraction. 7 minus 4 is 3 minus same base, we take one of the base and subtract the powers. 5 minus 1 4, this is going to give us 1. All right, so quickly now, then what is x to the power of 3? So what's going to give us this? So now to solve this, this is going to, so now we need to differentiate this. All right, so now dy dx of this, so dy dx, okay, so so we need to now find what the x of this. So it's going to become d of x cubed minus x1, all right, all over dx. So this is what we need. So if we apply this, if we differentiate this, all right, so if we differentiate 3, so this is going to become the derivative of 3x. Now remember here that x is power n. If you want to differentiate this, if y equals to this, then dy over dx is going to give us n times x into power x minus 1. N is going to, this power is going to multiply by x, then n minus 1. So this is going to give us, for this is going to give us 3x to the power 2, 3 minus 1. Right? So, so this is going to give us this. Taking of that, this is going to give us 3 times x minus 3 into x minus 1, and then minus, this is also going to give us x, so this is going to be 1 multiplied by x into x1 minus 1, so this is going to give us 3x to the power 2. All right, and then 1 minus 1 is 0, n to the power, so this is going to give us minus 1, x to the power 0. So therefore dy over dx is going to give us 3x squared and then minus 1. All right, so the option for this question is option C, 3x squared and minus 1. Right, so this is the answer to this question. Let's move on to the next question. Question number 2, we're told that if y is equals to 2x plus 1 raised to the power 3, find the y over the x. We can solve this question using two methods, or could use this method. So one of the first method we want to use is we can use function of a function, or we can use direct differentiation. But let's remember that if y is equals to ax plus b and all raised to the power n, first of all let's start with this. Now the derivative dy over dx, taking of this, that the dy over dx is going to give us, so if we differentiate ax, you're going to get a, all right, because this is the value. So we're looking at for what differentiation with respect to x. This will be 0 because it's a constant, so this goes to 0 and the answer is going to be a. All right, so take note of this. Also, I want us to note that if y is equals to ax plus b all raised to the power n, so let's differentiate this. What is this going to give us? That the y over the x is going to give us. So remember, if you differentiate using by first principle, all right, that this is going to be n times, if you differentiate what is inside the bracket, this is going to give us x, all right, and then we're going to have everything in the bracket ax plus b into n minus 1. So this is what we're going to get. This is going to multiply this based on the concept that if y is equals to a, if y is equals to x to the power n, that means this is all representing x to the power n, then the y over the x is going to give us n times x n minus 1. So this, everything in x is this, all right, so it's going to become n, which is this, times the derivative from what we said here. The derivative of everything in the bracket is going to give us x, because this is going to become 0, so this is going to go to 0. So the differentiation of ax is x, differentiation of b is 0, so get out of that, and then we still have our bracket into ax plus n, then n minus 1. So if we apply the concept here, this is going to give us that if y is equals to 2x plus 1 raised to the power 3, then dy over dx is going to give us, this is going to be 3 times, it's going to become 3 times the derivative of 2x is 2, the differentiation of x of 1 is 0, so it's going to be, so that everything there is gone, then 2x again plus 1 into 3 minus 1 based on this principle. So therefore dy dx is going to give us 3 times 2 is 6, right, and into 2x plus 1, 3 minus 3 spots, 3 raised to 3 minus 1 is going to give us 2. So see that the answer to that question is given as 6 brackets 2 into x plus 1 raised to power 2. So 6, so the option, correct option for this question is option D. Alright, option D. So that is the answer to that question. Alright, remember to pause the video and then watch over again for clarity. Alright, okay, now if you find value in this video, don't forget to head on to our YouTube channel. So hit the subscription button, turn on your notification and bell to get all our posts, our daily posts. Don't forget also to comment and then to share this video with students and people who really need this video. All right, let's move on to the next question. Now on to the next question, we are looking at this question which says integrate this. All right, find the integral of sine x plus 2. All right, so now let's move on with this question. Now what this question means here is that we're going to write this question. It's going to give us the integral. This means the integral of sine x plus 2 and the x. So what this means is that we can expand this. This is going to give us integral of sine x dx plus integral of 2 dx. Alright, so now when we integrate sine, what do we get? So we get cos, because they are standard integrals. Integrals of sine x gives us cos x plus c, because a constant, and integral of cos x will give us minus sine x plus c. Okay, so we'll apply that concept here, and not forget integral of a constant. All right, with a constant c, the x is going to give us cx plus c. All right, so if we integrate this, this is going to give us, integrate this is going to give us cos x. Okay, and then if we integrate this, 2 is going to give us 2x. Okay, so all of this is going to become and plus c. So the answer to this question, okay, you can see plus c or plus k, which is a constant. So the answer to this question is option B. So you can see that as straightforward as this. Remember our indefinite integrals. Okay, so this is one of them, and also this is one second. This is the third. There are a lot of indefinite um, integrals. So let's move on to question number 4. In question number 4, so if you remember, this first question we dealt with here is from indefinite integrals. You can see that there's no upper and lower boundary. But if you move on to question 4, you observe that you are given upper boundaries and lower boundaries. When you have upper boundaries and lower boundaries to which this integration is given, so you call that an indefinite integral. Definitely, because at the end of the day we're going to have values, unlike the other ones where we had plus a constant. The constant is going to go out. So let's look at this question now. Looking at this, we write this question as integral of 2 upper boundary 2 lower boundary 0 of x cubed plus x squared. All right, now the x. So what we're going to do from here, this can be expressed, so we can integrate this. So this is going to become integral of x cubed plus integral of x squared. Okay, now between the boundaries of 2 0 and 2 0. All right, so what this means here is that what do we integrate? So if we integrate x cubed, we have x. Remember, we said earlier from previous videos that integral of xn is equals to xn plus 1 divided by n plus 1. Don't forget that this is the standard integral for a power rule. So applying that concept, this is going to become x is power is 3, so this is going to become 3 plus 1 divided by 3 plus 1. Then here we have plus, then we have this, so we have x2 plus 1 divided by 2 plus 1. All right, now this 2 is within the boundaries. Remember, we're solving this within the boundary region, so this is going to be within the boundary region of 2 and 1, of 2 and 0, so between the bound of 2 and 0. How do we express this? So let's move on. This can be written as x to the power 4 over 4 plus x to the power 3 over 3. Remember, within the boundary region of 2 and 0. Upper boundary 2, lower boundary 0. How do we now express this? Okay, so we could decide to solve this. Now this can be expressed as, so this is going to become within the upper boundary. So we're going to solve one is going to be for the upper boundary, and then the other is going to be for the lower boundary. So it's between two regions. So the first region will have x 4 over 4 plus x3 over 3 for the region. So 1 is going to be for upper region, 2, and then we're going to subtract this with the lower boundary, which is 0. Same thing, same equation, x4 over 4 plus x3 over 3, and then for this time around, now we're looking at the lower boundary, which is 0. Okay, at this point you need to pause the video. What you need to do now is to substitute the value of 2 into wherever you see x, okay, and solve this. So now moving forward, this is going to give us, so this is going to become, so 0 raised to power, so this is going to become 2. Remember, substituting 2, first one is upper boundary. This is going to become 2 raised to power 4 divided by 4 plus 2 raised to power 3 divided by 3. All of this is raised to the boundary. Okay, so we've done this, then minus lower boundary of, now very well see x, we're going to substitute 0. 0 raised to power 4 over 4 plus 0 raised to power 3 over 3. So that's what we're looking at. Now if we go further to express this, so this is going to give us, so 2 raised to power 4 is going to give us 16 over 4 plus 2 raised to power 3 is 8 over 3. So we have this, then minus everything is going to give us 0. Okay, so everything is going to give us 0, so we're going to take all of this all the way down to 0. So with all of that out of the way, then it means that this is definitely going to be 0. So to move on from here, this can be expressed as 16 divided by 4. That's going to give us 4, so this is going to be 4 plus 8 over 3. All right, so this can be done as, this is 4, 3 times 4 is 12, 12 plus 8 is 20, so we have 20 over 3, which can be expressed as 3 into 20 is 618, so 6 whole number 2 over 3. So the option to that question is option B. All right, so that's the correct option to that question, 2 number 2 over 3. Remember to pause the video and then go over it again and again. Remember that for definite integrals, you need to find them. After you've integrated, you need to find the values between the regions. So after we got to this point, we needed to find the values for the upper region and the upper boundary and the lower boundary. Substituting, to do that, we need to substitute the values of x into wherever we see x. So for this, we'll add this, and then here we'll add to substitute the value of 0, and then we'll add this. So at the end of the day, we simplified and we got this as our answer. Let's move on to the next question. In the next question, we have to integrate the expression 6x raised to the power 2 minus 2x plus 1. So this is giving us 6x raised to the power 2 minus 2x plus 1. So what do we do from here? So remember we're integrating, okay? So we're asked to integrate this. So what are we going to do from here? Move on from this. This is going to give us the integral. Remember that these are all together and you can write it as the x. So this is going to become the integral of each of these. Remember, so the integral of 6x squared dx plus, sorry, minus the integral of 2x dx and then plus the integral of 1 dx. Right, so one of the ways to do this, we can do this, so this is, so we can bring this out whole 6 as whole number, and we can have this, okay, the x, so we can take this out. All right, also minus 2 integral of x and then plus integral of 1. All of this is a function of the x. Moving on from that, so this is going to give us 6. Remember, we integrate. Now let's start our integration. Integration of x is going to give us x2 plus 1 over 2 plus 1. All right, now this is going to become, remember this is 2 plus 1. Let's make that more eligible. Okay, so let's make this more eligible. So it's going to become x into 2 plus 1 divided by 2 plus 1, then minus, so we're done with this, then we have minus 2 into, this is going to become this invisible one here, this is going to become x into 1 plus 1 divided by 1 plus 1, and then finally the integration of a constant is always equals to the constant times x. So this is going to become 1 is going to become x, right? And then don't forget all of this is going to become plus c, because now, okay, whatever you want to use. So if we go on from this, this is going to become 6 into x. 2 plus 1 is 3 over 3 minus 2 x into 2 over 2, then plus what, x, all of that. So then finally plus c. Now if we go on from here, we can reduce this finally, and this is going to give us 3 here 1, 3 here 2, so we'll have 2x power 3, 2 here is 1, 2 here is 1, so we'll have minus x squared, and then we'll have plus c, we'll have plus x, so we'll have this plus x, which is this x here, all right, and then plus c. So this is the answer to this question from here. So you can see that our answer is 2x cubed minus x squared plus x plus c. Option B is the correct answer to this question. All right, so please, if you're joining us now, remember to hit the subscription button and turn on your notification bell to receive more videos. Like these videos and share with students that really need this video. All right, also drop your comment on the comment section, and you can let us know the next topic that you want us to bring your way. So for today, we're looking purely on differentiation and integration. All right, so let us know the topic that you want us to treat next and drop it on the comment section. Let's move on to the next question. Now, don't forget this is Daniel Maths, okay, Academy, and we're coming with you live on daily post. Next question here says that if x plus 2 and x minus 1 are factors of the expression ls cubed plus kx raised by 2 plus 24. Now this question is from the concept of functions, okay. Now functions, limit and functions. So remember where the topic is coming from, where the question is coming from is also as important, because you understand how to treat the question once you know the area to which the question is drawn from. That's very important. I would like JAMB students to take note of this. Very important that you know where each question is drawn from. Once you have the understanding, then I believe you can tackle the question very well. So let's write this again. This expression is written. Let's write this very well. Okay, it's written as lx cubed plus 2kx squared and then plus 24. So this is what we have. Now, remember we were told that if x plus 2, so first of all we have the factors. To have two factors, one is x plus 2, okay, and we also have x minus 1 as being factors. So what does this mean? It means that x plus 2 will be equal to 0, and therefore x will give us minus 2. So this is going to be our first factor, and then so we need to use this right to write an equation for this. So what that is, remember, it has to be equal to to 0, right? Now, so this is going to give us L. Remember, we're looking for L, so x is minus 2, so L minus 2 is about 3 plus 2k into minus 2 is about 2 plus 24, and this is equal to 0. So move on. This so this is going to become so minus this is going to become minus 8L. All right. Now then 2 square. Remember, minus 2 cube is minus 8. Minus 8 times L is minus 8L. Minus 2 is power 2 is 4. 4 times 2 is 8. So this is going to become plus 8k, and this is going to give us plus 24, right? So take this over here, it's going to become is equals to minus 24. So this is our equation 1. So but you can deal with this and reduce this, take off the minus sign by multiplying all through the minus sign. So we're going to multiply by minus sign. So this can be given to minus times minus is going to be 8. So we're going to have 8L minus 8k, and it's equals to 24. All right, so we can reduce this. We can reduce this down, so this can give us we can divide this by 4, so or by 2. So this is going to give us, let's look at that by 2. So this is going to give us 4L minus 8. 4L minus this, we're going to have this, divide everything by 2, man. 4L minus 4k is equals to 12. Is equation 1. All right, so we do the same thing for the other question. So now said when x minus 1 is equal to 0, therefore x is equal to 1. So if we go ahead and do that, you're going to get L into 1 cube, right, plus 2k into 1 square plus 24 is equal to 0. So this is going to give us L, take note of that, and then 1 square is 1, right, take note. So what we need to do here is moving on. So this is going to give us L times this is going to give us 1. This is going to give us 1 square is 1. 1 times 2k is going to give us 2k. Then plus 24 equal to 0. Solve this is going to give us L plus 2k. Take this over here, is going to give us minus 24. Right, so this is equation 2. Now we need to solve equation 2 and equation 1 together to find the values of k and L. So we're going to move on to continue this. So remember that the two equations we need is this 4k minus 4L minus 4k equals to 12. So this is going to give us, so using this is going to give us 4L minus 4k is equals to 12, equation 1, on which we can further even reduce this. Okay, we can even reduce this again by dividing by 4 and also by 4. So this is going to give us L minus K, and this is equals to 3. All right, so we have this as 3. So now let's write our new equation. So this is equation 1 and equation 2. Okay, you can see that equation 2, right? From the, let's look at that. Equation 2 is going to give us L plus 2K is equals to minus 24. L plus 2K is equals to minus 24, right? L plus 2K is equals to minus 24. This is equation 2. So could quickly solve this using simultaneous equation elimination method, which is always quite faster. So how do I eliminate K? Put a minus sign here, and that is gone. So what I'm going to be left with is, this is going to become 0 minus K minus 2K is going to give me minus 3K. All right, 3 minus minus 24 is going to give me equals to 27. So therefore divide both sides by 3, by minus 3, and this is going to give me that K is equals to minus, all right, this is going to give me minus 9. So K equals to minus 9, and I substitute that to find L. So substitute equation 1, to substitute into equation 1. Equation 1 says L minus K is equals to 3. So my L, I'm looking for L minus K is, remember, this is L minus, and K itself is minus 9. Please don't, if you do this, if you write it as L minus 9 is equals to 3, this is totally unacceptable because they are different things. This means that K is positive, but here K is negative 9. Take note of that, all right? So this is going to give us is equals to what? 3. So this is going to become minus minus is plus, L plus 9 is equals to 3. L is going to give us 9 minus 3 minus 9 is going to give us minus 6. So therefore our L is equals to minus 6 and our K is equals to minus 9. The option to that question is L is minus 6 and K equals to is minus 9. So option A is the answer to that question. Alright, so remember that this is how we solve this. Remember to pause the video and then go back to see how we work from this. Don't forget, if you're joining us, this is Daniel Maths Academy. Go to our YouTube channel. Remember to hit the subscription button on this video, right? Drop a comment right in the video, and then of course like and share to people that you don't know who might this can just be saved, who this can just save. All right, now take note of that, and let's move on to the next question. So see you in the next question even as we continue. Okay, now moving on to the next question, we see, so this we're going to just pause now and give you this to solve as a practice question. Don't forget that this, so now we move on to this question. Now this is Lx plus 2kx squared plus 24. All right, so you're going to use this to for your practice question. All right, remember to solve this and drop your answer on the comment section. All right, so we're going to start with this and drop this your answer on the comment section. Let's move on to the next question, and here in the next question we see that we're looking at question 7, which is a which deals with the function. All right, so what this question says is that g of x, remember that g of x is equal to x squared plus 3x, right? And we're given that we're asked to find g of x plus 1 minus g of x. What we're going to do is that wherever we see, so in this question, g of x is this. So we're looking for find g of x plus 1 minus g of x. So what we're going to do is that this is g of x. So wherever we see x, we're going to put x plus 1. So let's look for g of x plus 1. So this is going to give us, wherever we say x, we put plus 1. So this is going to give us x plus 1. So x plus 1 square, which is this, and plus 3. And wherever we see x, remember we're substituting with x plus 1. Right, so we solve this. So this is going to give us, expand this is going to give us x squared plus 2x plus 1. This times this is going to be x squared, and this times x times 2 is going to give us 2x and plus 1. Then finally we have this is going to become 3x plus 3. So we take like terms. All right, this is going to give us x squared. 2x plus 3x is going to give us 5x. All right, so this is going to give us plus 5x, and this is going to give us plus 4. So this is what we all will have for x plus 1. So let's go ahead and solve for g of, so let's look for g of x plus 1 minus g of x. So if we do that, this is going to give us x squared. So g of x plus 1 is x squared plus 5x plus 4 plus 5x and then plus 4. So minus, let me use so minus of g of x. So don't forget to put a minus sign. G of x is already given here as what? X squared plus 3x. So if we go ahead to solve that, so this is going to leave us with, so let's open this bracket. It's going to give us x squared plus 5x plus 4 minus times this is going to give us minus x squared and then minus 3x. So let's take like terms from there. So this will cancel off this. All right, then we're left with 5x minus 3x. This is going to give us 2x, and then this is going to give us plus 4. So if we look at this, all right, if we expand this, this can factorize. 2 is common, 2 is common with this. Bring out 2, we're going to have it left with x plus, then we have 2 in the bracket. So our answer here, you can see, is 2 into x plus 2, which is the correct option. There is option B. So option B is the correct answer to that question. Remember to pause the video and then go over it again. You see how that is done. Just direct substitution. All right, so let's move on to the next question. The next question, all right, is y. Differentiate y, which is equal to, y is equals to 5x plus 1 raised to the power 4. Find dy dx. Find dy over dx. Right, so that's what that means. Now remember, we've done this question similarly before. Don't forget to go back to the first video and then first or second video. You see how we solve this. Remember, so this can, so now let me use the second method to solve this. Let me use function of a function method. Now using function of a function, I'm going to say y. So I'm going to say let, now what I'm going to do is I'm going to say let 5x plus 1 is equal to u. All right, so I'm going to say that, and if I do that, then that means my y is going to give me u raised to the power 4. Right, so remember that's going to give me u raised to the power 4. Now, but remember I said that u is this, so I'm going to differentiate. I'm going to find du dx. So from here, my du dx is going to give me what? 5. All right, du dx is going to give me 5, remember. And then from here, I'm going to differentiate y with respect to u. So my dy over du is going to give me 4 times u into 4 minus 1. So that's going to be 4 u raised to the power 3. Now, using function of a function, my dy over du is going to give me my dy over dx. Sorry for that. My dy over dx is going to give me du over dx times dy over du. Anyone you want to use can say something. This can still be equivalent to, so you could turn this out. This can still be equivalent to dy over du times du over dx. So whichever comes first, and precedence doesn't matter in multiplication. So this can cancel this and we'll have that. So let's substitute our values to find what we'll have. Du over dx, du over the x is going to be 5. So I'm going to multiply that by my dy du is 4 u raised to the power 3. So if I go ahead, it's going to give me 5 times 4 into my u. Remember I said u is equal to something. So u is equal to, from here, let's u equals to, I'm going to take this u back. This is going to give me 5x plus 1 raised to the power 3. Right, so if I expand, so this is the same concept like I said in the first one. What you need to do, if we're using direct method, what you need to do from this is quite simple. So it's going to become 4 times here. So it's going to become 4 multiplied by the, what is the derivative of this bracket? Differentiation of 5x is 5. Differentiation of 1 is 0. We're going to take that away and put back our bracket plus 1. And then here we're going to have 4 minus 1. So this is going to give us 20 into 5x plus 1 raised to the power of 3. Same thing here, right? So you can see that if we take this further, it's going to give us 20 into 5x plus 1 raised to the power of 3. So remember that in JAMB questions, you want to look at speed, you want to work with speed and also work with accuracy. So it's important to know the different short methods to use, right, to arrive at your answer. So these are answer using direct principle, and then this is using substitution. Okay, now let's move on to the next question. Right now, in the next question, we were asked to find the derivative of the function y is equal to, so we're asked to find, to differentiate y is equal to 2x power 2 into 2x minus 1 at point where x is equal to minus 1. All right, so what we need to do here, we have to remember to differentiate this. All right, so what we need to do is that we can even start by expand this bracket, and then once we are done, we substitute that value. So let's open this bracket. All right, now what does this mean? This means that 2x squared times 2x, so this is going to give us, so let's move on. So this is going to give us 4x to the power 3. 2 times 2, 4. X to the power 2 times x to the power 3. And then we have minus, and then this is going to give us 2x to the power 2. So now we have this, let's differentiate this. So dy over the x, so dy over the x of this is going to, so if we differentiate this, this is going to become 3 times 4. 3 times 4 x to the power 3, right? Then minus 1, 3 minus 1, and this is going to give us minus, here this is going to give us 2, which is the power 2 times, this is going to give us 2x to the power 2 minus 1. So remember, this is the rule for differentiation. So take this to multiply the base number and then subtract the power. So this is going to give us 12x to the power 2, then minus 4 x to the power 1. All right, so which is same thing as 12x to the power 2, and then minus 4x. Remember, we are told that this, to find this value when x is equal to 1. So dy over dx is equal to this. Now at x is equal to minus 1, this is going to give us 12 into minus 1 square minus 4 into minus 1. We'll solve this further. This is going to give us minus 12. Now times minus is plus, so this is going to give us plus 4. What is minus 12 plus 4? This is going to give us okay. All right, so remember that there's a little mistake over here. Right, so this is supposed to be 12. All right, so this is supposed to be 12, and then because y will have 1 square is equals to 1. 1 times 12 is 12, so this is going to become 12 plus 4. This is going to give us 16. So the answer to this question is option B, which is what, 16. All right, take note of that. So we'll move on from this to the next question. Now in the next question, we, so this, look at these topics now. This is really this has to do with application of differentiation. So the topic, this last question we just did now, is on application of differentiation, and then this is also on application of differentiation. So if x is equals to 2 brackets, so if x, if s, so s is equals to 2 plus 3t and 5t minus 4. Find the s over the t, that means differentiate s with respect to t, and then find t at 5. So the first thing that we need to do here is to expand this. So if x is equals to 2 plus 3t into 5t minus 4, let's expand this. So 2 times 5t is going to give us, so we're going to do this way. Follow me please. This is 2 times 5t, this is going to give me 10t. Then I'm going to do 2 times minus 4 is going to give me minus 8. I'm going to move on to do this. 3t times 5t, this is going to give me plus 15t square, and then this times this is going to give me 3t times minus 4 is going to give me minus 12t. Take note, so let's cross check that. So this times 2t times 5t 10t, 2t times minus 4 minus 8, 2 times minus 4 minus 8, and then 3t times 5t 15t square, and then 3t times minus 4 minus 12. We'll take one from that, that is going to give us 10 10t minus 12t. Take note of that. Okay, so what is 10t? Take like times 10t minus 12t is going to give us minus 2t, all right, minus 8, and then plus 15t square. So you can write that as 15t square minus 2t minus 8, all right? So this is what we're looking for. Now we've written the expression and we can go ahead and find. So we've gotten s. So this is s, all right? So I have to go, next step is to find the s over the t. So differentiating this with respect to t. So the s over the t is going to give us, so if we differentiate, this is going to become 15. This is going to become 2 times 15, all right? So this is going to become 2 times 15 t raised to the power 2 minus 1 minus 2t 1 minus 1, and this is equals to, this is going to be 0. So this is going to be 0. So if we go on, this is going to be 30t, all right, and then minus 2. So that's what we'll have here. So this is for the s over the t. Now at t is equals to 4 over 5 seconds. Right, so what's this is going to give us 30 into t, substitute 4 over 5 and minus 2. So this is going to, 5 here is 1, 5 into 30 is 6, 6 times 4 is 24. So we'll have 24 minus 2. So the answer is equals to 22 units, okay, per second, per seconds. So the answer to that question is option C. So this is the answer to this question. Remember, you can pause the video and then go over it again. Don't forget to drop your question on the comment section. Now this is, with this will come to the end of Monday Maths, okay, with Daniel Maths Academy. If you're joining us now, community new, don't forget to hit the subscription button and turn on the notification bell so you can see more posts coming from us. All right, so we'll see you on Tuesday Maths with Daniel Maths Academy.